Okay, so this is the third installment. I'm going to try to put them out as a series all at the same time so people can see them in that way. Each one stands alone a bit, but really it's going to take this whole series to end up figuring out or doing about each one. And this one is really only about the golden ratio part of sacred geometry. And everybody thinks when they hear that that's all. No, 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 no. Well, it's got so much to do anything, and it's kind of the earliest theory of everything, kind of that Einstein idea, and it goes back way, way, way long ago, and people utilizing this. Imagine here what we're doing is starting out with a circle, and he's using a compass, which, if you look at the old interpretations of them, would have been made out of wood lots of times, but it has this ability to close and open. And you may have seen teachers use one with chalk and things on it, or even seen these in school that had that pointy ass end onto it. But in actuality, you have to have the pin set in there about the right amount too, or it gets a tilt to it, and it's tilted, and you can tell, like, where I'm going to draw a circle at here, if I tilt it, it becomes a different point. It loses this ratio. So it becomes important, and if you're going to do it wrong, you got to do it wrong every time. But what helps you in this is that you're, after you set a standard, which he's done with a circle and a point, then he can work off all of that. So let's let this get going while I start talking about it. But this is like the ancient Mies of the Sumerians and how you lay out something. And am I going to tell you that they actually did this everything? No, they didn't necessarily do all of this to make it happen. For what he's doing here is he's not doing the common interpretation, but as you can see, what he did was he took this exact locked-in measurement that is this ratio, and he threw it out from that point out to here, and then drew another dot of where that shows up on the circumference of the circle. And this is arc versus arc versus arc, okay? And then he's going to draw them from 2 points crossing over here and giving him in this ghost point, if you will, on the situation. Let's let this go so it doesn't get too bad. But so he's not figuring the same thing as it would be a plot of land, but in some ways it still very much is. And I'll kind of show you how this can be that plot of land that we showed, because we were talking about the golden ratio of the how it got smaller, and the room, and then the room's got the bathroom in it, and then the bathroom's got the extra thing into it, and he's going to basically show you that, and he's going to show you how it goes both ways. Now we got to say something and show something here. Well, he put his hand right over the top of it. You saw that arc that was going across there, and he just stops it because he's only really trying to find this exacting point. But if he carried that on through, that overlaps this circle and makes Vesca Pisces out of this point. He could do the same thing over here, and it would have done the same thing. We're going to show that variation on it, but if you want to see this Fibonacci sequence, it comes out of it sideways one way and diminutive in a growth, and the growth pattern is that amount of the golden ratio. So that's what makes it all fit together somewhat. So we can get this exact point. And now I'll draw across it, and now I really have an X through solid north, south, east, west for certain. And if you look, whenever I get these ghost points that are out in between, those are like what you would call them equinoctial points in between the points. And you see how he makes sure that he's putting it on exactly the point whenever he does it, because if he gets it off by even the width of a point, it's going to put his little line off here just a hair, and that'll start getting your thing off. And people for a long time thought, well, he's only getting off a hair and then he does it and everything, and it's like, no, he's getting off exactly this amount of a hair and then utilizing it, and that's what makes it different. So now we get this crisscross British flag going on, if you will, of the equinoctial signs that are going on. And now we get an internal version of squaring the circle. See that? Hope it's showing up well. So now he's going to pick a ghost point and go crossways from center of the circle to far corner and take this measurement. So this is the extra ratio, difference between straight and corner, and he throws it out here as another ghost point. And now he's actually cheating 2 steps, but it automatically makes the cross by him being able to lay it down flat onto it. And you can imagine somebody, if they were to take a string and run it across what they already had, they could go out from that point and meet that ghost point. So now he's able to erase part of this, and I kind of wish he didn't, but then again, you need to. It starts to get to be junk, and he erases a little part of it and shows you that now he's got the square inside the circle. And now if you'll look, this looks like that cut up piece of land in the sacred ratio of a box, and it took all of that just to get there. So then he goes diagonal again, like he had done up here, finding the far ratio. So he takes that and uses that diagonal. This is the shape of a flag. This is the shape of a playing card. This is the shape of a lot of things in that size. We would call it a rectangle, and you can make rectangles of any size. If you watch what he just did there and cut off, he's making identical points, making sure it's measured right, and he's finding that point across here. All he's going to do is box that off, and by transposing that, he's cutting this box with the third thing, like he cut that and that off. You'll see here. So now we've got the ratio in the little box. So we got the ratio going, and the ratio going into the little box, and then we've got the ratio of the little box. It kind of looks like a bed with a pillow on it situation. Now he's going to do another arc across the center point of it, finding from the center of these 2 positions, going across and making sure he marks the point. And he's going to bisect that room also into the smaller bed with a pillow, let's just say it that way, and he gets that measurement and he arcs it from that point, verifying to there. And if you'll look, we have a slowly curling in point there. And so, like I said, it doesn't matter how many vents a nautilus got, the shell shows it. It's not about the pine cone seed, it's about the pine cone itself. And if we transpose this secondary measurement, and in just a second he's going to make a mistake, okay? And he should go ahead and draw this line here and go across. But now whenever he takes that last dot, he is off the dot just a hair, and it doesn't even show whenever he does it there, but it does cut into this line just a hair. But he gets this bisecting dot again, which is just like the small version of the one going across here, and he catches that dot just a hair off, transposes it just a hair off. It's really on the edge of a dot. Let's go in close on that so you can see. And he puts that dot there, and then when he draws it back of that line. It should be the cross point, right? And then he draws that dash, which is just a hair off the dot. You can probably see that it's off the dot. And then he sets this wrong just off of that. And if you look at that other dot and how it's cutting into the side of the circle of the dot, but he grabs that ratio, and you're going to see it fail here, but it's close enough for the response. But you notice how right here, how it cut just short of the circle, and it didn't touch like it did at the top, showing you where it went through that, but it didn't through the other. It's to the last point, so it really doesn't matter. But if you're using that and transposing it, making a pyramid, something as small as being off that dot will throw you off by a couple of inches down a couple of 100 foot, and it might get you off a hair. And I'm not trying to make excuses for pyramid makers not making it exact. And so people have often said, well, why do you think they built the pyramids? And I'll go, man, well, you can say it's a tomb and it can do all those things. Was it a sign of hope for all of mankind? And why was it a sign of hope? Well, it showed all the sacred geometry and mass mathematics. And was it set up so if we ever got screwed up again, we'd have something to look at? And some people believe that, no, the pyramids were built way before, and the Sphinx and all this timing into it, and that's what it did to the ancient Atlanteans, if you will. And by seeing the pyramid and being around it long enough, all of a sudden, boom, their little popcorn happened. And a lot of people believe that it all happened like popcorn that way, and I felt it had a lot to do with it. But then I knew there was older civilizations, so you got to find something. It doesn't just really go popcorn, does it? And so when we look at this, it's really a ram's horn coming in, ding, sacred geometry curling in, and you don't have to put those little curls that they say, well, that's not part of the ratio. And you're like, look, 100% of it doesn't have to be part of the ratio. The shell that you're looking at has got it. The only way it would do it on their ratio is if it came out and it exponentially grew every little shade 1.6. It couldn't put near as many in there, spokes, if you will, in there as that. So it's not going to really show that type of thing. So this is in the Fibonacci sequence. This is what the sequence that he put into fractals, and it makes it on your computer, and used to be the old screensavers back in the day. Either that, or you'd have these ones where something went bipping around on the screen, but then you remember the ones that were like little spirograph designs that kept changing every once in a while? That's all sacred geometry too. And now they've got it in mathematical little programs, and they've got this little thing where it's supposed to do this display, and they say, well, fibrate it and spread it this much. And there you go. Boom. Well, how much do you spread it, and what's the ratio? 1.618. Yep. When they do some things in hexadecimal, it ends up coming out to 1.9e something else, but because that's based on a different ratio than tens, what's it come out to? They've even got it in binary, and it's 1.10101010101 binary version. So let's take a look at this again here. We're going to go to golden ratio, but then we're going to, and that's in the pyramids, and it's finding, and you can lay down the pyramid. Oh man, you can lay down the Great Pyramid, and where that place is up top here, you can lay down and say, well, if this was a box and this was 1/4 of the box, imagine it's a cube, and you could put 4 of those together and make a giant square box. This is a square box, and you set it off on the bottom of it, and it was swirled around. And that little bathroom that we keep talking about, that's the Queen's Chamber right there. Funny how, yeah, the bathroom is the Queen's Chamber, isn't it? Yeah, and so you go to the bathroom, you go to the bedroom, and in the bedroom, she's got a big walk-in closet. There's a bathroom. Yeah, it's kind of like that. So this golden ratio. So being ill-prepared and flipping, we're going to go ahead and look at what they say about sacred geometry. Sacred geometry. This is one of the pictures I was trying to show you for what I've been talking about, and they show it in representation sometimes, and it's not complete because this is a cluster, pile of metal, whatever you want to call it. But at the same time, what this is that dodecahedron inside of that 8-sided dice, inside of a 6-sided dice, with that 4-sided dice pyramid in the middle of it, with a circle which is showing half the earth, and then the picture that's in the middle of that is the sun. Now, whenever they use this representation, they said this is God. This is how it all works. They have representations where they use this, and the sun's at the center of things, and there's where our planets lay out, and they're laying out in a ratio. The only thing that screws that up is we got an asteroid belt. But then there's other things that screw up the ratio, from everything just being like the gas giants, being oversized for their place and stuff, and it doesn't quite fit just right. But then again, scientists are saying, well, is that a proper ratio though for the planets to go out? Would there normally somewhere in the center be a giant thing that's near a size of a sun, because we see all these double sunned ones that we found now, and it has two suns, kind of like Star Wars, but that didn't happen here, and because of that, you'd end up with this type. And would that be somewhat common? And we're searching to find out how common we are, and everything, but there's a representation there. I can tell you he's drawn it wrong. Everything's bent a little to the left on this dodecahedron because you can see too much of this panel in comparison. It's like laid out like wall, just a little bit. So did he use sacred geometry in drawing it? Not sure, bud, because it doesn't look like it, because you're having to draw things on angle and tangents, and it just doesn't come, like that. Got another representation of that. So there's that Nautilus. And yeah, those fin things don't matter, but you see what they're there. And that's the same thing found in a ram's horn, right? That's the same thing that's in a galaxy. That's the way they look. Because they swirl and they're spinning and they're doing. Because the worlds are spinning and they're doing. And we're in a little solar system that's like a micro version of this, and we're spinning and doing. We're in this little Goldilocks area. Where are you at? We're in the square. Oh, well, the square was supposed to be, the square is a 360, and it was the Earth. Yeah, that's where we are, aren't we? Hot damn. This is starting to look conspicuous. So you look at these temples in Hindu temple, and I can show you a bunch of them that in the center of it has a swastika. But if you look, they got a sunflower in the center of that. And then they got the Star of David. And there's this sectional thing put all around it. And people have said that that's representation of God. And this is a symbol that marries heaven to earth and all this other stuff. And you can see how they put it around, and it's all in ratios and cut in half. And when that's cut in half, it has a view out. And there's been one guy that's taken one of these drawings like this. It's not this exact one. And then said, that's Stonehenge. You go, what? You go, well, if I lay it all down and do it right, then all these gaps end up between other ones, although there's a gap here too, and here there isn't one. So this doesn't have everything Stonehenge has in it, but it's got the whole thing. Well, how does that make the star? Oh, man. And we could talk about Stonehenge and sacred geometry as a separate entity, because that's going to take a while, but bam, look at this. And here we have the sun at the center of planetary rings, and there's this area that's a couple of them that's too hot, and then there's this zone that's held back by a certain amount of gravity, and then there's this sacred red, white, green, black, red, white, green, black that goes around. Yeah. In the zone that we're in. What you got for me next? Oh yeah, it's in sacred carpet. And that just looks like fractal patterns or something else. And you go, yeah, well it makes that too. And there's a reason you think that's pretty, and flowers are pretty too. It's because they all use this stuff. Sacred geometry, meanings to certain geometric shapes, proportions, associated belief that it is a god in the geometry of the world. And what's geometry? Well, if you break that down, geo is world, and meter is to measure, and it's the measurements of the world. And when they talk about geometry, that's what it was built on, is figuring out the measure and the relationships of the world and things that go with it. Oh, you can use it to make and plot out a piece of the land, and that may be your known world at that time. But it's found in religious structures. Which one do they show? Even ancient Hindu temples. It's all around. Everywhere Mary went, the land was sure to grow. Aryans had this hooked up everywhere. From ancient Egypt, North Africa, all around the Mediterranean, all the way through Europe, all the way to China, all the way down. Hindus got it. Chinese got it. They show it in ancient Aztec temples and Mayan things, whether you believe that they built all that crap or not. And it's amazing. Other churches See if we see any. Well, they're going to show like the Parthenon and things like that, but I could see that. Temples, going to show the same picture. Wow, that's funny. Sacred geometry, and they do show Göbekli Tepe. I'm going to zoom in there. Show me temple. Ah, you bastards, don't do that to me. Gonna do it. No, you're not. So they show Göbekli Tepe. And I wish I could zoom in a little bit, but this circle here, and this circle here, and this circle here make a triad, and going through, bisecting the pyramid of the triangle, zoom, right through there is west. I'm sorry, east. And so, dang, but also it's the geometric ratio, but I've showed how each little circle, or even inside of this circle, whenever they have the two ones there, that's probably not the variation we just showed where you went one circle, but remember when I said, well, if you made a second circle out here on this side and that side, it would make Vesica Pisces, then that would put these pillars right in that. Well, if you don't make it a triple and you just make it out of two and they crisscross like this, my God, I can't do it, like that, there's Vesica in the middle of that too. Wish I had two little circles so I could just show you an idea or a picture. And then that would be the center of that, running out that room also. And then that also is east-west aligned, and so are these two pillars, and so are these. And it's like, well, they're all lined up with heaven and got these things going on that's all based, and all these plants have it going on, and grab a sunflower, and there it is again. Pine cones, and you see these guys walking around with pine cones and baskets and pictures and Sumerians and stuff. You're like, what the hell's going on? And he's like trying to tell you. I'm shoving it in your face. Here's a freaking pine cone. I'm Johnny Appleseed. We're making this shit happen, and this is the sacred stuff. And he's shoving that freaking pine cone in your head, you guys. They make a lot out of that, and I've heard some crazy shit. But, and it's not just that either. For there's about 3 things that are right about that same concept, and it just shows you the onion effect and how life's like a box of chocolates. And what I mean by that, Forrest? Well, I mean that whenever you bite into a chocolate, sometimes it's got nougat and then a cherry center and stuff, and there's layers to that thing. You never know what you're going to get. So where else do they got this sacred art? Mosques. It's laid out like that. Well, how is that laid out like that? Well, there's this center circle, and then based off of that are these circles all the way around it. And in the center of those, they put these little spires. Like at the Pope's little house over there. He's got that ancient obelisk there, and it's not a circle, and it's an 8-wheeled spoke. Built like that thing we were talking about just a minute ago. And yeah, it's got the same thing. It's a sundial, too. Word. Yeah, and it's hooked up with that whole little concept. And you don't think it's like, well, you're just carrying it on. We all got that concept. Everybody had it going on. Some people don't really have it going on so much anymore, and people don't remember or don't know. Even sacred monuments they found out in places like this, and okay, well, it's got this thing around it and then a circle of it and everything. Well, that's a ratio. And then the stack of it going up's a ratio. That damn building over there has it too. And you look how it's big windows and almost the same size as the next, but then the little windows are on top of it, and it's got that Disney effect on it. Found in such place also as tabernacles and an art, and the scribblings are all over that thing. Religious structures, we already did that. Timonoi, piece of land cut off and assigned. Sacred groves and laid out trees and Celtic practices and stuff, and there's these sacred groves, and you can't see it anymore because there have been too many generations, but at one time they cut out the trees except for certain ones and kept these major trees and used representation. This is the sacred oak, and this, that, and the other. These ancient druids, and cleared it out, and they would lay them out in that situation too. All kinds of things. Little village greens that people talk about, and they found it in that, and holy wells. I could do one on wells and religious art, which quite often has this iconography that people think of now today as one thing, but in ancient days showed you another. For this kid here that's got a boom, got that on his head, is also a little sacred geometry spot where he's showing you the 4 strikes, and you can get across carrying that down out of it and that concept. And that's a terrible one to use. That just says religious art. But if they said sacred geometry and religious art and you could click on it, it'd been another picture. So Plato said God geometrizes continually. The belief that God created the universe according to a geometric plan has ancient origins. Plutarch attributed the belief to Plato, writing that Plato said God geometrizes continually. In modern times, the mathematician Carl Friedrich Gauss applied this quote, saying, God arithmetizes. As late as Johannes Kepler, a belief in the geometric underpinnings of the cosmos persisted among some scientists until we got the ability of a telescope to focus on the distant blurs that they used to call nebula. What does nebula mean? Well, in Latin and stuff, and based off a German root, it basically means like a cloud, a mist or a cloud. You know, nimbostratus clouds and all this stuff. So it was a planet that was like blurry a little bit. But when we got the badass telescopes finally working on it, and really that didn't come in effect, honestly, until we got the Hubble Space Telescope, where we were able to look at a lot of these things. But we were able to still see a bunch of galaxies, and you know this, way long ago, and finally figure out, well, hold on a minute, we're not just living in a solar system with these sparklies, but there's a whole galaxy going on. And then round about time of your grandpa, somebody with a better telescope all of a sudden figured out, well, I was looking at some of them blurs, and they're all spirals and things and swirls. And after looking at a bunch of them, I think those, which are swirled up just like this, are what we're in. We're in one of those. And we're just kind of over here looking through it. And that's what we see as the belt of stars that Sumerians talked about. And they started seeing more and more of them. And some of those things were exploded suns and made nebulas. And we still call Crab Nebula and things today because it was that smoky thing. But the other ones are called Galaxia. And Galaxia, Gaul, had a sign of greatness. And they knew that even though they're looking at a little bitty smudge of dot, that's this great big old thing far, far away. For the ancient Sumerians said that those stars in your sky that you're seeing, they're just like our sun, but just as a torch in the distance, far, far away. I always thought that, well, man, that's some hell of some insight right there. And that's whenever I knew, oh, they started farming and this, that, and the other. Nowadays we go, no, they didn't start farming. They came up with the plow and this concept into it, but it looks like all that comes from way before that. Now we're willing to shove what, whenever I was doing all of this academia, what was 3500 BC and coming into it, and they popcorn, and there they go. And now people are, and that was new for everybody. That's not what you learned in regular school. You had the academic go out of it to get this type of thing and learn a little bit more. Now all of a sudden that 3500 BC is doubled, and damn well by 7 grand. Well, I asked a question a long time ago. So they went off on this prognathism, and your jaw sticks out a little bit, and they say, well, primitive people, you can still see they got that going on. And so once you became hunter-gatherers, that all went away. Then we started looking at ancient skulls, and you look at Cro-Magnon, man, and he has almost none to zero prognathism. And so I raised my hand and had a question. Well, if that's the way it works, then we've been doing farming for a whole lot longer than these Sumerians. And I've been vindicated now for double that age. But I'm telling y'all now, it goes whack way before that. Were they already farming at the place and everything? No, they may have been making pilgrimages to it and therefore not farming around it, and they weren't allowed to farm around it. But could that area have been farmed? Oh yeah, it could have been. It could have been farmed and wiped out and then regrown to where it is now, and then turned up, drying up like a desert like it is now. And you'd see just what you're seeing there. There wouldn't be much more of a sign that they ever farmed it. Except you'd have irrigation and things, so they didn't have that level going on for positive. Nowhere near where we're looking at. And that's what I want to figure in these other sites that we look at. For Göbekli Tepe's not the only one. There's a couple of these guys that date to the date of, or a little older maybe. And around that time and a little bit sooner. So now we're able to cover that little area of time that was going between all of a sudden this 3,500 year jump, which all we had really was Catalhoyuk and these things in there, and we've got about a couple of 1,000 year gap again. Okay, well that fills back in with a little bit of some of the people that were going on at this time, at least at these one civilizations. Were there people other places? Yeah. And you're fixing to find the Natufians come in and they start making these ancient stone circles that look just like the ones that are found in old sub-Saharan African Cape, and these weird cattle crawls and things. And it starts going from there down into Egypt, and it looks like by those cattle crawls they went a lot farther than that back in the ancient days. The Hofmeyr site shows a skull that's Caucasoid at 38,000 BC down in the cave, the Hofmeyr site. Blombos cave way down in the point shows a red ochre symbology thing kit, basically, that shows up for, and it's now been supposedly dated to 73,000 or something like that. At first they were saying up to 100 grand, but 73,000, that kit still used all the way in through Cro-Magnon kinds. A variation on a theme, but they have some shells, not this kind, but more clam type shells, and they've made up red ochre in the same way people made up red ochre all the way through into the Egyptian times, and then they start chemically messing with it to make it to where it's insoluble in water and immune to flame, as the scribes used to say. But I've showed that in another vid here recently. We're going to go on now, and y'all mull that around for a little bit, and I'll throw the next one together, because when I get to the point of showing you all the different ratios that fit with all these different things, I'm going to have to find somebody's video where they have some of this information and try to put it together in pieces, and then stop and talk about it and do these things, because just standing here and talking at a shell and stuff isn't going to make it on this next part for any way, shape, or form. I almost need to be able to show you math a little bit and geometric designs. Coming soon, though, putting it together for you. Peace.